Hello and welcome to How Do I BI, a mini-part screencast series on SQL Server Analysis Services 2008 based on my book, Smart Business Intelligence Solutions with Microsoft SQL Server 2008. This is Lynn Langett. I'm a developer evangelist with Microsoft in Southern California. In this edition of How Do I BI, we're going to take a look at some of the included data mining algorithms in analysis services. We're going to do this from an implementation standpoint rather than from a conceptual standpoint, and I encourage you to read my book to get more conceptual background. We're going to look at naive Bayes, clustering, and decision trees. Before we do that, we'll go over the FAQs and gotchas around the implementation of these particular algorithms. Generally, when you're implementing any data mining algorithms, you're going to want to make good use of the included visualizers or browsers for those algorithms in BIDS. Particularly if you're new to data mining, that's really going to help you to understand whether or not you've selected the most appropriate algorithm for your particular business situation. We're going to make extensive use of the included AdventureWorks samples. For this particular situation, we're going to look at the targeted mailing structure and then the included models, which actually are 4. We're going to look at 3 in this screencast as listed here: naive Bayes, clustering, and decision trees. We'll come back to the neural net in a later screencast. It's important to understand when you're implementing a particular data mining algorithm that these algorithms support the processing of data which is associated to particular content types. In particular, we're going to look at the difference between continuous and discrete or discretized. Also, some of the algorithms weight attributes differently. In the case of the ones that we're looking at in this screencast, naive Bayes, all attributes are weighted equally, and that's an important consideration. Another thing for you to consider when you're setting up data mining algorithms is whether they predict, group, or both group and predict. And also, you may want to take a look at the advanced algorithm properties so that you can accomplish additional tuning. And we'll look at all these things in the upcoming screencast. We're going to be taking a look at implementing data mining models based on particular data mining algorithms using BIDS for SQL Server Analysis Services. To do this, I've opened up the sample AdventureWorks and loaded the included mining structures, of which there are 5. Before we get started looking at particular algorithms, I'll show you the simple process to create a new mining structure and a new mining model. To do that, inside of Solution Explorer, you click on the Mining Structures folder and then right-click to expose the context-sensitive menu, and then click on New Mining Structure. Click Next, and then you'll be asked whether you'd like to select as source data relational data or cube data, and we'll select relational data here. The next step in the wizard is for you to specify which data mining algorithm you'd wish to include in your mining structure. Using this wizard, you will create a structure with a single data mining model with one algorithm. You can subsequently add more than one mining model based on different algorithms or different implementations of those algorithms to that same data structure. And we'll start with decision trees in this case. And then we'll be asked to pick our data from a data source view that's been defined in this project. So we'll just select AdventureWorks DW. Then we'll be asked to select the case and nested tables. So in this case, we want information about products, so we'll select that as case. And in a subsequent screencast, we'll talk more about what nested tables are and why you might use them. Then we'll be asked to select the key column for the product table if it has not already been pre-selected by the scanning of the data. In this case, it's correctly selected the product key. And then we'll be asked for the input columns and the predictable columns. So I'll select color as an input column and days to manufacture as a predict column. You notice after I do that, then the suggest button becomes available. And when I click that, then the sample data is evaluated for possibility of inclusion based on an internal scoring method. And you'll see that it's ranked and then marked for input. And some attributes you'll see were not included and other attributes were included. So we'll just click OK, and then those changes will be made. And then we'll click Next. The next section of the wizard here asks us to specify the column's content and data types. It does detect them and by default, and then we can click detect for the internal algorithm to make further changes here. And again, we'll be covering this in more detail as we continue in the screencast. And then we'll click next, and the next section of the wizard asks us whether we would like to hold out a certain percentage of data to use to test the validity of the mining structure that we create. We can specify this as a percentage, or we can specify this as a number of cases. And this capability is new in Analysis Services 2008 because this is a common step in data mining. And rather than doing this manually, it's included as part of the wizard. And now we've created our data mining structure with our first data mining model. The last option is we can allow drill through. I'm going to go ahead and cancel out of this. The reason I quickly ran through the wizard is because, similar to creating OLAP cubes and dimensions for OLAP cubes, creating mining structures and mining models is really quite simple in BIDS. And in some ways it's actually too simple given the complexity of what it is that you're creating. I would highly recommend that before you start implementing mining models, you spend a little bit of time with the included samples, and we're going to do that in the rest of this screencast so that you can better understand some of the options that are available and some of the algorithms that you might choose to work with. So the first mining structure that we're going to take a look at is the included targeted mailing. And you'll see that this is based on relational data. It's a single source table, and we have a data source view inside of the mining structure work area, and if we right click on it, we can actually explore the source data. And the assumption here is you may not have administrative control over the source data, so these little viewers are included inside of BIDS so that you can have an understanding of the data that you're pulling in. And you'll see that this is just very much like almost like a spreadsheet in that it has attributes about people who have purchased bicycles for this particular business case. You can look at this in the table. You can look at it as a pivot chart and drag and drop information over onto the pivot chart, pivot table working area, also a pivot chart, and then you can look at it as a pure chart. And this is just so that you can get a sense of what the data looks like as you start to decide how you're going to implement data mining models. Over in the work area here, you'll see that each of the attributes, the columns, have associated properties, and this is where we start to take a look at some of the things that are unique to setting up data mining models. One of the areas that I want to point out for your attention is this attribute in the properties for each associated column called content type. And you'll see that for the age column, this is set to discretized. And if I click the drop-down list next to the content type attribute, you'll see that the choices that we have here are discrete, continuous, discretized, ordered, or cyclical. And probably we'll just start with discrete versus continuous. Discrete means put into a series of groups. So or the ability to be put into a series of groups. Discretized is how we've set this age category. And this means put into a series of groups. So rather than 1, 2, 3, 4, 5, 1 through 5, 6 through 10, so on and so forth. And this is done by a method set internally unless you choose to adjust the algorithm differently. Now if we click on commute distance, you'll see that that's discrete. So it's some values that are being able to be grouped. Now let's contrast that to another attribute that's been selected for inclusion in these models called yearly income. And this has been set up to continuous. So this is not bucketized, if you will. This is simply person A makes X value, person B makes Y value, so on and so forth. And this is processed differently by the data mining algorithms when the data mining model outputs are built. So it's important for you to understand and use these properly. I encourage you to consult the Books Online documentation for more detail and also my book. And be aware that certain algorithms support certain content types. And as we drill in here, we'll see that in more detail. Now to do that, we're going to click on the Mining Models tab, and this is going to show us that for this particular mining structure, we have actually 4 included mining models, and in this screencast, we're going to talk about 3 of those 4. The 3 that are included are the most commonly used in many ways, and we'll start with the simplest, Nave Bayes, which produces as output simply grouping all your attributes together, and then predicting one or more values. You can see that each of the attributes here, or source columns if you will, is marked with the value of input or predict or key. And we could change this if we wanted to and then reprocess. Our options are ignore, input, predict, or predict only. And notice in Nave Bayes that the yearly income attribute is set to ignore, and this is because this algorithm does not work with continuous attributes. It's just not designed to work that way. If we wanted to further tune the algorithm, what we could do is click on the header in the mining model section and then go over to the properties and scroll up, and we could go to the set algorithm parameters. This is a little bit confusing in the interface, so I wanted to show it in the screencast. So in addition to the properties that are available in the properties section, if we click on the algorithm parameters build button, this will open up parameters that we can configure. Now this is a very advanced usage of data mining. However, you may find that as you work with it more and more, you will want to have access to at least looking at what the default values for these advanced properties per parameters are, and in some cases you may want to change them. So I wanted to show you where that was in the interface. Another thing that you're going to want to do is use the mining model viewer, as I said in the introduction, so that you can get a sense of how this data might be visualized. One of the challenges in the world of data mining is to translate the output into something that is meaningful for the end users. And we have included all of these viewers inside of BIDS, as well as in some of our client applications such as Excel 2007 with the data mining add-ins. These same viewers are available, and we're starting to make them available in other situations as well. So if you click on Bike Buyer here, you can, in the dependency network viewer, the mining model viewer, you can see that all attributes are equally associated. However, on the left we have an association adjustment tool, or slider if you will, and if we drag that down to where it says show only to us the stronger links, then some of the nodes will no longer be connected, so that ultimately we see that the most correlated attribute to whether or not a person is going to buy a bike is how many cars they've owned. The next most correlated attribute is how old they are. The next most correlated attribute is total children. And here we start to be able to see how this data might be used in an actionable way, for example, marketing, so on and so forth. And I found in introducing data mining to a number of different audiences that really working very much with the viewers has been a very successful strategy. Now this interface is pretty complex. You'll see inside the mining model viewer you have actually 4 different types of viewers associated with the Nave Bayes viewer for this particular mining model. Now we have some other mining models included, and let's just go back to the mining models tab and talk briefly about them, and then look at how the mining model viewer makes those available. So the next one I want to talk about is clustering, and you'll see that clustering here is able to work with all types of attributes, whether they're continuous or discrete or discretized. And we have the predict value set to Bike Buyer here. So if we were to take a view of clustering in our mining model viewer, we'd go back to that section, and then under the mining models we'd select clustering, and then it will take a minute to render, and we will have 4 types of new viewers. The first one is a cluster diagram viewer. Now when you first take a look at that, it's actually showing the density of results. Darker colors are more results for the entire population. What it can be more meaningful is if you select from the shading variable a particular attribute such as Bike Buyer and a particular state such as 1. So then you can see that the clusters where people had the highest tendency to actually buy a bike were cluster 1 and cluster 5. Then you might want to drill in and see more information about those clusters. So then you can look at one of the other viewers that are included, the cluster profiles, cluster characteristics, or cluster discrimination. I'll just quickly click on cluster profiles, and then we'll close out of the mining legend here, and you can see how the attributes are correlated to this state of the particular clusters as opposed to the entire population. And you may not remember which cluster it was, but I believe it was 5 that had the highest propensity for actually buying a bike. So you can see, for example, that the age range for your customers that are buying bikes is between 40 and 47 to the greatest extent. And yeah, there's the value of buying bike, the pink there, and you can see that education is looks like almost evenly split and gender looks almost evenly split, and so on and so forth. It just helps you to visualize the results. Now you can drill more granularly than just looking at a graphic. As you see when I pass my mouse over this, it gives you the actual case count in terms of the results. So the last algorithm we're going to look at is decision trees, and this is one of the more popular ones because it creates, in terms of a result, if we go back over to the mining model viewer, something that I have found customers are able to understand very quickly visually. So I'm loading up the decision tree viewer here, and in the decision tree viewer we're looking at a series of nodes, and we've got this set for bike buyer, and we're going to change the background to 1, which is those who bought a bike. And you can see that the most closely correlated factor using this algorithm is the number of cars owned. So this is the same as Nave Bays. But what is interesting is it gets a little bit more granular. If the state of number of cars owned is 0, then the next most closely correlated factor is where a person lives, with the highest correlation being Pacific because it's the darkest color, and if you pass your mouse over it, you can see the number of cases. If the number of cars owned is 2, then the next most correlated factor is yearly income, and so on and so forth. So this should serve as an introduction to the first 3 mining model algorithms that are included inside of BIDS. As we continue this series, we will talk about using and implementing some of the other mining model algorithms that are included. Thank you.